Okay, good evening everyone. On this side, and today we are going to start with our previous topic, that is optimizer statistics. So we are reiterating with the same topic again and again because we should be aware about the statistics, what and all types of statistics we have to gather to make optimizer aware about the performance improvement of the database. So back to the topic again about optimized statistics. Today will be the last topic for last session for the optimizer, and from the next session we'll start with some other reports and all that. So under optimizer statistics, first question you should ask, why does the optimizer need statistics? Why there is an importance for statistics? As we have discussed earlier also, you guys should be familiar with that without statistics, updated statistics, optimizer will fail to select the best execution plan. So this is the scenario where you have to select the best possible plans by gathering the statistics. And if something bad happens during the performance of the databases, or something sometimes happens, some bulk deletion happens, some bulk updation happens, so on that time statistics used to change, and but optimizer is not aware with that. So I will also let you know what is the frequency to gather statistics of a database object. So moving forward, the answer will be to generate the better explain plan. Second, boost query performance, reduce cost, and capture better cardinality. Better cardinality means the value should be unique, and obviously, for selecting the best execution plan, the less cost will be the priority. The third thing is the it helps in boosting the query performance, and the third is it generate the best execution or explain plan. So the question was, why does the optimizer need statistics? Because of these things. It will generate the best explain plan. If optimizer is not aware with the statistics, it will generate the bad execution plan, and the it won't boost the query. It will devast the query. It will badly impact the performance of that query. It will the cost will increase. That means IO, CPU, and other resources will lead to acquire some resources, and the query will uh, lead maximum times for its execution. And last is better cardinality, so it is also the important parameters. So this is why optimizer needs the statistics. So let's think in a different way. Optimizer need to know what type of things. Why, if we are referring to the gathering statistics, so what type of statistics the optimizers need to be aware of? So number one is type of data, whether it is a structured data, unstructured data, semi-structured data. Obviously, we are working as a Oracle DBA, and the Oracle itself is a structured data format, which is a RDBMS. So what type of data is there? It's a number, character, or whatever. Second is data distribution, the distribution of a data, how the data is being distributed in the databases. That is also plays an important role. Approx number of rows, how many number of rows are there? According to the number of rows only, the optimizer will select the best possible plans. If rows are more and optimizer is not aware with the statistics, then it will throw a wrong execution plan. Null and distinct values, these values should be specified using the constraints. And the last is clustering factors. Next, what type of statistics can I gather, what it collects, and what to find where to find the information. So look at this diagram. This is the flow chart. This is the optimizer statistics. If you are referring to a collection of optimizer statistics, so we have the table statistics. Under table statistics, we have to gather the number of rows, number of blocks, average row length, number of distinct values, number of nulls and columns. Under column statistics, if you want to gather stats for individual columns which has more cardinal values, that means you have to collect the information like number of distinct values, maximum minimum values, number of nulls, and all that. You can even gather the statistics of index also. That means how many number of leaf blocks are there, branch leaves levels are there, what are the clustering factors is present. So under indexing, we have two types of index. So let me tell you the name. The first indexing is what we known as a B-tree index, which is widely used in our daily life nowadays. We are creating the B-tree index where the values are unique, or what you can say where primary key is there. Apart from that, one more index is there, that is bitmap, which contains the low cardinal values, and b-tree contains the high cardinality values. So this is the basic difference. I will let you know about the flowcharts and how it is created and what is the functionality and all that. Apart from that, there can be a system statistics. This statistics will be from the OS perspective about IO performance and utilization, CPU performance and utilization. Apart from that, there can be multiple extended statistics that like dictionary gather statistics and all that. We'll discuss in the later sections. So as of now, you should be aware with these many important things like table statistics, column, index, and system statistics. And how to validate what type of statistics is being gathered and what are the tables that is present, how to find the columns names, how to find the statistics, what statistics has been gathered for the columns level, for index level. So there is a view at the bottom of the this presentation slides. From DB underscore tables, you will be able to identify what are the size of the table, what is the name of the table, under which owner it belongs, and all that. From DB underscore tab underscore statistics, you will be able to identify what is the statistics in the table format. Okay, for table statistics. And apart from that, if you want to identify the history statistics of the table, you can use this one also. So you should try each and every views and try to check what and all things you can identify from these views. Same for columns. If someone will ask you in the organization how to find the column name for a particular or column statistics for a particular table, how to do that? Using DB underscore tab underscore columns. And apart from that, for statistics, you can check DB underscore tab underscore col underscore statistics. Related to indexes, how many indexes are there from DB underscore indexes? For checking the statistics, DB underscore IND underscore statistics. So related to DBA, whatever views is related to DBA, you have to trigger it from the sysdba user. And related to users, suppose if you are working on particular table named as EMP and the user is Scott or suppose HR, then make sure that if you are logged into HR user or Scott user, then you will be able to trigger the views like users underscore indexes, users underscore tables and all that. Make sure DBA related views you should trigger with the sysdba, sys user, and the rest of the views, if you're logged into the different user, you should trigger with the users underscore views. Moving forward, best method to gather statistics. Now we are aware with the functionality why we used to gather the statistics and all that, and we are also aware how many types of statistics we have to gather like table, column, index stats, and system stats, and how to validate it whether statistics is being gathered or not. All that these things are under views like db underscore and users underscore. Coming to the next point, the best method to gather optimizer statistics. How to gather the optimizer statistics? So these are the packages. Look. So dbms underscore stats. From these packages, we can execute the gather statistics for a specific table, gather statistics for a specific index, for a table, for a schema, for a database, for a system. If you'll say, okay, if someone will ask you how you can gather statistics for a specific index, so you should say that there is a procedure called gather underscore index underscore stats. From that, there is a gather underscore table underscore stats. So from this, you can gather statistics for a table, columns, as well as an index. For a specific index related thing, you can use index underscore stats. For a schema related thing, if you will suppose HR user, you want to gather statistics for HR user. Under this HR user, there can be multiple indexes, tables, views. Okay, there can be multiple database objects. So you want to gather statistics for all. That means if you can gather statistics for schema, everything will be for all the database objects, statistics will be gathered. So you can gather statistics for the schema also with the procedure gather underscore schema underscore stats. If you want the database objects and the database user statistics gather, then you can trigger this view gather underscore database underscore stats. Apart from that, for system stats like CPU and IO statistics, you can use this command gather system underscore stats. So these are the procedures via which we can gather the statistics. And on the right side, it is showing that what and all things uh, that is being gathered the statistics for which we can gather the statistics. Apart from that, do you know when dbms underscore stats packages was first introduced? So this is introduced in Oracle 8i. So we are in currently 21c, but in the market everyone is using 19c now, right? And most of the companies are even working on 11g and 12c. So remember, still we are using dbms underscore stats, and it has been introduced in Oracle 8i. After 8i, 9i has been implemented. After 9i, 10g has been implemented, and then 11g introduced, 12c, 19c, and 21c. Okay. So you'll say, okay, how to do the practicals, how to do the gather statistics. So these are the examples how we can proceed further and we can do the statistics gather. So number one is this examples. Suppose if you want to gather the statistics of a table. So we have the procedure, right? We have discussed now gather underscore table underscore statistics. Someone has asked you that there is a user called Scott and the table inside this user is EMP. Can you please gather the statistics for this EMP table? So for gathering the EMP table statistics, you should use this procedure, right? Gather underscore table underscore statistics. And to run this procedure, you should have dbms underscore stats terminology. This procedure name. exec means execute. With this procedure dbms underscore stats and the procedure name, what procedure you want to execute. And in bracket parenthesis, you have to give the specify username as well as the table name for which table you want to gather stats. If you want to gather the statistics of a schema also, then instead of gather underscore table underscore stats, you should mention the gather underscore schema underscore stats. And you have to give owner name equal to, that is Scott. That's it. You don't have to, not need to specify the table name here. That's fine. Yeah. Apart from that, we have second example where we have added some extra parameters like what? Cascade equal to true. Apart from that, we have used estimate underscore percent. Apart from that, we have used method equal underscore opt. Apart from that, granularity we have used. Apart from degree, we have also used. See, similar way, if you are gathering the table statistics, we have used three more things like estimate underscore percentage, method opt, and degree. So you should be asking that, okay, what if we have triggered this command instead of this? It won't impact anything. The same, both the commands are pretty much similar, but you are adding some extra parameters to uh, get these procedures executed as soon as possible. This is the ultimate goal, because stats gathering also, this job is also will take a hell amount of time to get it executed. So to make it faster, to make the procedure execution faster, we should add some additional parameters. So coming to that, what is the additional parameter? One of the most critical decision you have to take is what sample size should be used. um, this you should ignore. Yeah, this one. So gather statistics jobs taking more time. If some gather jobs like dbms underscore stats, if you want to gather table stats, then dot. gather underscore table underscore stats. So this job is taking lot of time, and if any jobs running in the database level at a database level which is taking lot of amount of time, that means it is taking huge amount of resources from the database, and it is impacting the database performance also. So what should be our ultimate goal? To improve the performance of this stats gather job also. This is also a part of tuning. Even you are doing the tuning, for tuning also you are doing the sub tuning to gather the statistic job in the faster way. So how to make it faster? So you should include some more parameters like auto underscore degree parameter. That means if you are running the gather statistics job, you should run in the parallel with auto degree options. Suppose if you're triggering a backup, okay, and the backup database size is 500 gigs, and you have run in parallel, okay, if you have run in parallel, or you have allocated the channels like 5 channels, right? Then what happens for 500 GB database? Suppose say approx time it would take 3 hours or 5 hours for the complete full database backup, okay. For 500 GB database, it would take 5 hours to take the backup of full database. So what we have to do for 5 hours, someone has said it is taking huge amount of time. So can you please let me know how to improve the performance of this database for taking while taking the backup? So you can do it by adding the channels. Okay, so once you added the channel equal to 5, then what will happen, this 500 GB will be split into 5 channels, 1 2 3 4 5. That means what, in first channel 100 GB backup will happen, under second 100. So on the all the channels it will split into 5 channels, and all channels 100 GB will be start happening the backup, right? So what will happen here, if you have taken 5 hours to complete this backup, now it will complete in 1 hour. Why? How it has happened? Because we have split that backups into 5 channels to improve the performance, right? But it's not that case that you can use 5 channels always. This can be decided on the basis of number of CPUs. If CPU is 2 and you have added channels 5, your database will crash. So channelings and all that all will be decided on the basis of CPUs and all that things. Always remember. So similar way, suppose auto degree also is a parameter where you can run this gather jobs in parallel to execute in the faster manner. Apart from that, concurrently with concurrent parameter, this parameter you can use to improve the performance of stats gathering job. Even it will be a table gathering, schema gathering, or whatever gathering you want to. Even you can use both at a one go, concurrent and auto degree. So let's see this parameter, auto degree and concurrent, and auto degree and concurrent. What happens here? If you're using this parameter auto underscore degree, it will identify large tables and define a specific degree of parallelism, DOP. Okay, it is asking for applying or running the jobs in parallel. It can be 2, it can be 3, it can be 4, it can be 5. But remember, degree of parallelism is very critical. If you are extending the degree of parallelism, if without knowing the number of CPUs, your database will be crashed. Crashing means it won't impact the data, but database will be down on that scenario. It won't respond to you. So what to do now in this scenario? You have to ask your seniors on this. You have to while getting the KT sessions, knowledge transfer sessions, you should ask these questions: what can be the degree of parallelism in this scenario if you are running the stats gathering job and all that? Else, if you are smart enough, then check the number of CPUs. If number of CPUs is 8, then even you can use the degree of parallelism 5. Don't go beyond 8. Max to max you can use the parallelism concept to 8 if CPU is 8. If CPU is 16, then you can increase that also. So it depends on that. And how to check the number of CPUs? ls cpu command at the OS level. Concurrent, this will allow to initiate multiple statistics gathering job. So with this option, multiple gathering jobs will be initiated. And with the two combinations, you can do at a one go. And yes, if you are using degree of parallelism, you are using auto degree parameter, that means it will acquire huge amount of IO, it will acquire huge amount of resource, it will take huge amount of resource. It will consume CPUs. Okay. So many, if there is a pros for this, then there will be a cons for the same thing, right? If you want to improve the performance, if you want the job to be completed faster way, you have to give some more input from the database, right? That means what? You are taking the resource from some other user and you are giving to this user to get the job done very fast, right? That means you are acquiring the resources which is being used by other user and you are taking for your work. That means the performance of this user will be degrading, right? Just to improve one backup or just to improve the gathering statistics job, the other jobs or other SQL queries which is running with the taking the same resources will respond very slowly. So uh, in order to avoid this scenario, we should avoid DOP's concept. Always remember, don't dare to means you can try it, but don't try uh, to apply anything, any jobs to run quickly using DOP. If you're running it as with a DOP, your job will be executed as soon as possible, but there can be an impact in a database also. So always try to avoid this DOP, degree of parallelism. Okay. So this is all about optimizer concepts. So we will start from the reports analysis and all that, SQL tuning and all that, and we'll do the practicals as well from the next session. So till then, you should go through these concepts and let me know if you guys have any issues. Thank you so much for your time and patience. Bye bye. Take care.